And happy Monday, my party people. Welcome in to our class on simple versus compound probability. So here's the gist of today, my party people. Number one, we just want to understand the difference between simple and compound probability. That's one of the things that we're really going to drive home today. Number two, we're going to be understanding the differences between some of these situations where you might see the word and thrown around. Like, what are the odds of, rolling a 3 and flipping a heads on a coin? We'll definitely talk about how to handle those situations. Also, we'll handle or situations where we say, what are the odds of rolling a 2 or rolling a 3? We'll absolutely talk about those as well. And then from there, we'll have some practice test level questions to help you build that speed and confidence up. That way you understand the nuances and can explain what you're talking about at every step. And so, just want to remind you that this is the first of 2 simple versus compound probability lessons. Today, right here, if you're watching this as a recording, you may see the next one right after this. If you're here live, we are doing this tomorrow, and I will be including the recording as always. So, with that said, my party people, let's get the party started here with our first page of notes. So, here's how we're going to do this. I'll give you a chance here to take a moment and write down what you see here. And then once we're done writing things down, then we can put those pencils down and just have a discussion of what all of this actually means. I think that's the best way to handle this, because the last thing I want you to try to do is I want you to not try to write and listen at the same time. So with that, go ahead, take a moment, write this down, and then from there, I'll explain these notes. And let's go ahead and review these notes here. So, our first page of notes, let's talk about what probability really is. Probability is the same thing as a chance, the chances of something happening. So I'm going to go ahead and highlight these two things together. Probability and chance, for the purposes of today, they're the same exact thing. So you're going to see over here that I talk about how it's calculated and a little example over here. But long story short, if there's anything that you pick up from today's class, it should be this. When we are trying to calculate probability, this is the way I like to think about it. Probability is the same thing as calculating the wanted outcome divided by all outcomes. So basically, what we want divided by the total possibilities. So this is the simplified layman's terms of really what we're doing today. We are calculating probability, and to calculate a simple, straightforward probability of this event happening, it's going to be the number of ways that what we want can happen divided by all the possibilities. So again, probability is what we want divided by all outcomes. My party people, give me a yes or a no in the chat box if that simplified version makes sense before I get started on the calculation and the example that we see here. Sweet, sounds good. You know me, the one thing I like to do here is keep things simple in the beginning before we move forward to all of that fun in a couple of slides when we start practicing, all right? So let's go ahead and move it forward here to how it's calculated. So again, this just shows right over here exactly what we just saw right here. So how it's calculated is basically just dividing the number of desired outcomes, so what we want, and we're going to divide that by the total possibilities, all the possible outcomes. So if we're taking a look at this example here at the end, for example, the probability of flipping a coin and getting heads, it's 1 out of 2, or a fraction right over here of 1 over 2. Now, this might seem pretty straightforward when we're flipping a coin, but staying true to these foundations is going to be way too important when we start talking not about coins, but perhaps about rolling a dice or a deck of playing cards. So we have to be ready to expand upon this in a couple of moments here. But if we're talking about this, when we talk about the probability of flipping a coin, everybody, we have heads and we have tails. How many total possibilities is that? When we're flipping a coin, we have heads and tails. Yeah, so that makes 2 possibilities, heads or tails. And that's where the 2 comes from down here. Again, all outcomes is on the bottom. There are 2 possibilities when flipping a coin. And then up top, you're going to put what you want. If you want heads, then we just want one out of those two total possibilities. So I know this might seem very, very straightforward, especially if we're just refreshing on this. But one more time before I continue, does the gist of this make sense? What we want divided by total possibilities. Okay, so with that, let's go ahead and move forward to our second page of notes. And then after the second page of notes, we, I believe, have one more before we get into compound probability. And, this is where things are going to become really important in terms of paying attention to the specific details here. So here's page number 2. And this is where we start talking about the word or. This is going to be really important here. So let's take another moment. Let's take these notes down. And we're going to talk about right over here how to calculate the probability of rolling a 2 or a 5 on a 6-sided dice. So let's go ahead and get that done, my party people, and then let's type ready in the chat box once we're ready to move forward. And let's take care of our second page of notes. So here's, again, this is a really important part here, so let me just start by highlighting that this is the second page of notes, and here we go. So the use of the word or, this is really going to be important. My party people, if I said that, hey, I'm hungry and I could go for scrambled eggs or oatmeal. All right, everybody. So if I say that, I could definitely go for scrambled eggs or oatmeal, and someone brought me oatmeal, not scrambled eggs, they brought me oatmeal. Is that still okay? Is that okay? Right on. Yes, that's right. The answer is yes, because of the way the word or works. Or means that this works or the other thing works. Yeah, you have choices. Exactly, iPhone. So boom, when we use the word or in probability, it's the same thing. When we're talking, let me go ahead and come back over here. When I am using, copy this and paste this over here. So when we are discussing the idea of, what we want, if I said, hey, I want scrambled eggs or oatmeal, that would mean that we have two outcomes that we want. We would be okay with one of them being scrambled eggs or the other one, number 2, being oatmeal. So I know I'm using food. Hopefully we're not getting hungry. And if you are, I'm just going to laugh real quick. But with that, when we talk about the word or, we are adding these probabilities together because more than one thing can work. Everybody, before I continue to the nuance, to the nitty gritty over here, does that make sense on the surface? When we use the word or, we're going to add the chances of this or the other thing happening. Right on. So again, to calculate or, we're going to add the probability of each event, and only if they cannot happen at the same time. So they are mutually exclusive. And I'll get into what happens if there is, hey, what if there's overlap? We'll talk about that too. But for this first example here, let's talk about the probability of rolling a 2 or a 5 on a 6-sided dice. My party people, let's go ahead and talk about a 6-sided dice. Let's go ahead and remind ourselves, if we have a dice right over here at the bottom left corner of your screen, I'm going to draw this little dice here, and let's say we have a 1 there, 2 right there, 3 right there, all the way up to 6, right? So when we're talking about the probability of rolling a 2 or a 5, everybody, how many numbers are going to satisfy the conditions that we're talking about? How many numbers? Yeah, 2 of them. 2 of them. Because when we talk about all of the possibilities on a 6-sided dice, we're going to have a 1, a 2, 3, 4, 5, and 6. And the numbers or outcomes that we want are going to be a 2 or a 5. Those are the ones that will work. So 2 of the outcomes out of the 6 total possibilities, that's what we are looking for. That's what we want. And that's what we will accept as satisfactory. Now, there's one more thing that we have to talk about, and it has to do with the standardized testing. So with your test, when you're dealing with fractions, and hopefully no one's getting nervous about fractions, because don't worry, I'll help you out. But when it comes to answer choices that are fractions, everybody, what's that S word that the fractions that are answer choices typically come in? What's that S word? They typically come in, exactly, yes. They typically come in the simplified form. That's how they come in the answer choices. So when we're taking a look at 2 over 6, everybody, is that the simplest form? Is 2 over 6 the simplest way we can write that fraction? Thank you. That's a no. So let's help each other out here. More so helping me out because you already know I can't do math. So let's go ahead and move this over here, zoom on in, and let's remind ourselves of how to simplify. Remember that when we simplify, what we need to do or think about is what number can go into both the top here and the bottom? What number can we divide out of both the top and the bottom? And yeah, the answer there is going to be 2, for sure. We can divide 2 out of both 2 and 6. And to prove it, let's just go ahead and do it. Let's divide the numerator by 2. Everybody, 2 divided by 2 is going to give us, correct, that's going to give us 1. And then 6 divided by 2, everybody, that's going to give us 3. That's right, 6 divided by 2 is 3. And so that's the ugliest 3 I think I've ever drawn in my life. But there we go, 1/3. So your answer choice is going to come in that form, 1 over 3. If you get 2 over 6, you're not going to see 2 over 6 as the choice. You're going to see 1/3. So let's zoom on out. So does the idea or the premise of using the word or make sense, everybody? When we are asking for the probability of this or that happening, we are adding the probabilities of the events. And yeah, Eugene, I got you. So the way that we got 6 here on the bottom, the way that we got 6 is because we are counting all of the possible outcomes with rolling a dice, and there are 6 numbers. So all of the possibilities, there are 6 possibilities. That's where the 6 comes from. And the 2 comes from having 2 and 5. Those are the 2 options that we want. So those are 2 options out of the 6 total options that we'd like. And that's correct, Morgan. The only time, so let me just say this for the recording. So Morgan's question was, so the answer to probability will be fractions, not whole numbers. And my answer to that is almost always yes. Almost always yes. And the reason I'm saying almost always is because the only situation where you're going to have a whole number is when that whole number is 1, where the probability is 100%, which is represented by just the whole number 1. And so, for example, if we were saying, hey, everybody, we have ourselves a 6-sided dice, and we want to find the probability of rolling a number, rolling a 1, 2, 3, 4, 5, or 6. Well, if I am doing 6 possibilities that I want, divided by 6 total possibilities, Morgan, help me out. What's 6 divided by 6? Yeah, that's going to be 1. And that's going to be 1. 1 meaning that it is certain, it is guaranteed that you will get that outcome. And if we think about it, yeah, if I'm rolling a dice and I say that, hey, I want an outcome of 1, 2, 3, 4, 5, or 6, any one of those numbers will be okay with me. It's going to have to land on one of those numbers. It's not going to magically, turn into a 7 or an 8 or a 9. Not going to happen. So hopefully that answers your question there, my party people. So with that, boom, let's go ahead and let some more folks in there. But there we go. And KT, yes, we can absolutely see some bigger numbers out there, especially when you have those probability questions where we're dealing with playing cards, because you have 52 cards in a deck and you might be dealing with certain manipulations in there. But don't worry, again, in this class and in tomorrow's class, I'll be walking you through nice and easy. But with that said, my party people, I think that is enough for simple probability. I have the 3rd page of notes for handling overlaps, but I want to make sure that we get the fundamentals down first. So I'm going to skip over here to compound probability, where we typically see the word and I'm going to highlight this right here. We typically see the word and this is honestly, for today's purpose, is going to be the most complicated part of today. But once you understand the difference between or and I think it's going to be a much easier time. So my party people, go ahead, take another moment, write this down, and then we will go ahead and go through the example once you're done writing. All right, so let's go ahead and go over the compound probability notes. So compound probability, here's generally what this means. Compound meaning more than one. So compound probability is the chance of two or more events happening together. So plenty of different situations that we can kind of construe this in, but here's how we're going to calculate it. Let's say you have two events that you're trying to find the probability of happening at the same time. For example here, let's say we're talking about flipping a coin and rolling a 4 on a die. So if we're doing that, if we are flipping a coin and rolling a 4 on a die, well, those are two separate things. We have the flip of the coin, and then we have rolling the dice. So again, one more time, two events. And when we have two events and we want the probability of one thing from this one and one thing from that one happening at the same exact time, that is when we are talking about compound probability. So when we're trying to calculate compound probability, you'll see the word and splattered all over right there. And what we'll do is we will multiply the individual probabilities. So let me repeat that one more time. To calculate compound probabilities using the word and, so this and that happening, we will go ahead and then calculate the probability of one thing happening right here, the probability of flipping a coin and rolling heads. Everybody help me out one more time. When it comes to flipping a coin, what are the two possible outcomes? How many are there? Yeah, exactly. We have two possible outcomes, heads and tails. So that's where the 2 right here comes from. And then from there, everyone, how many of those options are heads? Correct. Just one of them is heads. And so that's where we get right here 1/2. That's where we get that. Then we want to know, again, the probability of flipping a coin and getting heads, which is, again, the 1/2, and rolling a 4 when we roll a dice. So let me highlight this here in green. So rolling a 4 on a dice. Everybody, if we have a 6-sided dice, that's going to be 6 possibilities. And then from there, how many of those are a 4? Well, just one of those possibilities. So that's where this comes into play. 1/2 times 1/6. And so with that, when we multiply these together, I'll have 1/2 multiplied by 1/6. And from there, when we multiply, that's going to get us our final answer. Remember, when we multiply fractions, all we really need to do is multiply. Let me zoom on in over here. All we really need to do is multiply straight up. The top, or the numerators, multiply together. 1 times 1 is 1. And then the denominators, we'll multiply those together. Everyone, 2 times 6 is what? Correct, that's going to be 12. So we have 1/12, and that's that. And there we go. And that would be the final answer, because that is the probability of not just flipping and getting heads, and not just rolling a 4, but the odds of you doing both of them at the same time. That's what we're really discussing here. The chances of both of these things happening at the same exact time. So when we use the word and, all you need to take away from this, the word and means multiply. The word or means add. The word or, we are adding. Let me highlight this over here. The word or means add. And then the word and means multiply. So again, just to keep it simple, you can write it like that. But to get more nuanced, that's everything else. So who here is ready to start practicing some word problems? Good. Sounds good. So let's take it nice and slow here. We have almost 20 examples to go through in today's class. We may not go through all of them, but this is going to be a great class nonetheless. So here we go. Let's take a look at example number 1. Here's what I want you to do first. I don't want you to try to answer the question. Don't want you to do anything other than this. We're going to read the question first. And once we read the question, I want you to tell me if we're dealing with simple or compound probability. That's really it. That's really it. So let's read the question sentence first. It says, if the spinner is spun once, what is the probability that it lands on the number 4? My party people, how many events are we trying to calculate? How many events are we trying to calculate? Yeah, just once. If the spinner is spun once, what is the probability that it lands on the number 4? So I think we can all agree here that this is, again, one event. We want one event. What does that make this? What kind of a probability? Is this a simple probability or a compounded probability with multiple outcomes? Correct. Simple probability. And so remember that when we calculate a simple probability, it's simply going to be what we want divided by all outcomes, all of the outcomes that are possible. So the number of ways we can get what we want divided by all of the possibilities. So let's take into account what we're seeing here. The question or the problem reads, a spinner is divided into 6 equal sections numbered 1 through 6. If we spun it once, what's the probability that it lands on the number 4? Okay, sounds good. Let me go ahead and draw a spinner because you know me, I can draw things perfectly without the use of technology, per usual. And then I'm going to take the straight lines that I know how to draw perfectly, of course. And I'm going to do that and that and that. Let's say we have this spinner into 6 equal sections, and we're going to label it 1, 2, 3, 4, 5, and 6. All right. So my party people, I see. Okay, look, I'm going to say this because there are, for the recording, there are folks in the chat box here saying that they doubt my abilities in drawing straight lines without technological help. Guys, come on, you know me. I am the Picasso of our time when it comes to drawing freehand. So with that, let me get back over here before these students make me end class early. So here we are. Let's take a look here, everybody. What do we want? We want to land on the number 4. Everybody, when we take a look at this spinner, how many ways can we land on 4? Yeah, just once. Exactly, just once. Right here, let me use green to kind of, shade that in. There's one way that we can get the number 4. So when we're filling in our little formula over here, what we want divided by all outcomes, the probability is going to be 1 divided by all of the ways, all of the other options, like all options, including that 4. How many options do we have, everybody? 1, 2, 3, 4, 5, and 6. 6 options, and we want this of the 6. So 1 out of 6. And there we are. Very straightforward when it comes to simple probabilities without hearing the word or and or anything like that. Pretty straightforward. Who here is feeling pretty good about this now that we see a couple of examples? Cool. Sounds good. So we're going to slowly turn up the heat, and we're not going to get anywhere near ridiculous. I got you. But let's take it up just a tiny little step so we can continue trying to understand this. So let's go ahead and get into this next example. So in this example, everybody tell me really quick, what is it that we want? What do we want? Tell me in the chat box, what do we want here? Ariane, correct. We do want orange, but what about orange? We want to know, and I know I'm being very strict here, but we want the probability of selecting an orange, right? We want the probability of selecting an orange. So let me highlight that there. What is the probability of selecting an orange? So let's go ahead here and say that what we are trying to calculate is the probability of getting an orange, and we are going to divide that by all possibilities. So all outcomes. So with that, let's take it nice and slow here. If we are taking a read and we say that it says a basket contains 8 oranges and 12 bananas, we're going to choose one fruit at random. What's the probability of selecting an orange? Okay, sounds good. So my party people, how many oranges are there to select? Correct. There are 8 oranges that are shown here. It says a basket contains 8 oranges. Perfect. So I'll go ahead and write 8 because there are 8 oranges. Then from there, everyone, what are the total possibilities? When I reach my hand into this basket, what are the total possibilities of this? Correct. I saw some folks say 8, saw some say 12, but the correct answer is 20. Because all outcomes, my friends, we have 8 oranges and 12 bananas. To calculate all of the possible outcomes, well, we'll add up all of those outcomes. We can choose 8, from 8 oranges and from 12 bananas. that makes a total of 20. So here, it's going to be 8 divided by 20. Now, what did I say earlier? Again, I'm just helping you out with those standardized tests, preparing you for the test that you're going to be taking. So when we take a look at 8 over 20, that may not be an answer choice that's shown, even though it's correct. Correct, we need to simplify. We always need to be ready to simplify when needed. So when we take a look at 8 and 20, give me a number that can be divided into both 8 and 20. And we generally want to use the biggest number that we can. Yeah, 4 will absolutely work. 4 will absolutely work. So over here, we can go ahead and divide the 8 by 4 and then divide the 20 by 4. And no worries, don't worry at all. Once we're done with this problem, I'll zoom on out and I'll give you a chance to write everything down. I got you. So we have 8 divided by 4, everybody. That's going to be 2. And then 20 divided by 4, that's going to end up, being 5. And there we are. And there we go. After we simplify, again, whenever we need to, whenever we can, we should be simplifying. And then once you have that simplified answer, boom, we're all done. And there we go. A nice, simple probability example here. So with that, I'll give you a chance to write this down, and then we'll move forward to the next example. And let's give this next one a shot, everybody. So if we're beginning every problem with the same strategy, which is, again, reading that question first, it's saying here that if a crayon is selected at random, what is the probability that it is green? So what is the probability that it is green? Everybody, what are we trying to calculate? Are we trying to calculate the probability of one event happening, or are we trying to calculate multiple events happening? Correct, just one event, exactly. So we want the probability that it is green. So again, the probability of getting green is going to be the number of ways that we can get a green crayon divided by all crayons in this case. So with that, let's just go ahead and do some very straightforward arithmetic. Everybody, when we read, it says an art box contains 10 crayons, of which 4 are green and 6 are red. So how many green crayons do we have, my friends? Correct, we have 4. So we'll write 4 up top. And then when we're talking about all of the crayons, how many crayons do we have? Correct, it's going to be 10, not 20. It is 10. Because we have to read here, and when we read it says, the art box contains 10 crayons. It has 10 crayons. Of those 10, you have 4 that are green and 6 that are red. Everybody, what's 4 plus 6? Yeah, 4 plus 6 is 10. So this is just verbiage here. It's just context. There, yeah, no worries if we went too fast. It's all good. It happens. But it says we have 10 crayons. 4 of them are green, 6 are red. So it is 10 total crayons. And so we have 10 in that denominator right there. And once we have 4 over 10, like we've always seen, we know that if we can simplify it, we absolutely should. Everyone, 4 and 10 are both divisible by what? Correct, both divisible by 2. So we'll do that. 4 divided by 2 and 10 divided by 2. 4 divided by 2, that's going to give us 2. And then 10 divided by 2, that's going to give us 5. And so the correct answer here will be 2/5, or 2 over 5. And so Nadesha asking, hey, coach, so we don't touch the 6 at all? We do. We did use the 6, but in terms of calculating all the crayons together. So the 10 was already given to us, but if it wasn't, you would still get the 10 by adding the 4 and the 6 together. And so you may have gotten something different if you used 20, 6 out of 20. When you divide them both by 2, you would have gotten 3 over 10, and that wouldn't have been the correct answer. And again, just to remind us here, because I saw a couple questions in the chat box, how are we using that 6? So all crayons, when we think about all crayons, we have 4 green, and we add that with 6 red, and that's how we get 10 total. And that's where that 10 comes from. Yeah, I know. It's definitely easy to get caught up here and think that, oh, wait, it's 20 because we have 10, 4, and 6. Not quite. Not quite. Here it was 10 total. They're just describing what the contents of that 10 are. So with that, I'm going to end the talk on the simple probability